Howdy, everybody. So today we're going to be talking about limiting reagents and molarity. So the first thing that we're going to have to do is we're going to have to write out the balanced molecular equation that's described when copper chloride reacts with sodium nitrate. You can pause the video and go ahead and give that a shot if you want. Okay, so let's think about this. What's happening? So we have copper 2 chloride, which means that this has a positive 2 charge, this has a negative 1 charge. So we have copper chloride, and then we have sodium with a +1 charge and nitrate with a -1 charge. So it'll look like that. Since we have a cation, anion, this is going to be a double replacement reaction. So the copper will stick with the nitrate and the sodium will stick with the chloride. So whenever you're doing double replacement reactions, just do the switch first. Switch the elements. Then go back, look at the charges, and make sure that the chemical formulas are correct. So the first thing we're going to do is put copper with nitrate, and then we're going to put sodium with chloride. If we look at sodium chloride, right, this is +1, this is -1, so that chemical formula is correct. If we look at copper nitrate, this is still +2 and that's -1, so we need 2 nitrates in order for that to be correct. So now what we need to do is actually balance the whole entire reaction. So you'll see on the left side, the reactant side, we have 1 copper. On the right side, we have 1 copper. On the reactant side, we have 2 chlorides. On the product side, we only have 1, so we need to put a 2 here. Then on the reactants side, we have 1 nitrate, but on the product side, we have 2 nitrates. So we need to put a 2 over here. I'm going to move this stuff over some. Delete these guys. Okay. So now we've got 1 copper, 2 chloride, 2 chloride, 2 sodium, 2 sodium, 2 nitrate, 2 nitrate. Perfect. The next step that we want to do is write out the balanced net ionic equation for the reaction above. In order to do this, you're going to have to check your solubility rules, right? If it dissolves in water, it's going to what? Dissociate, not dissolve. We'll have to split those ions up. So let's go ahead and look at that. So copper chloride, that's definitely soluble. So we have copper 2+, we have 2 chlorides with a -1 charge. All group 1A elements and all nitrates are soluble. So we have 2 sodium, 2 nitrate. Then copper nitrate, that's also soluble. And sodium chloride is also soluble and will dissociate in water. Right? So what happened was that each one of these molecules or ionic compounds dissociated in water. And they dissociated because they were soluble. And the way you can check to see if they're soluble is to look up your solubility rules. Okay, so the next part of this is we're going to take 15 grams of copper 2 chloride and react that with 20 grams of sodium nitrate. And then the question is, how many grams of sodium chloride can be formed? So the important thing here is that, one, we want to look at our balanced molecular equation. The net ionic is going to be a little confusing for this one. So make sure you're looking at your balanced molecular equation. And I've already given you the molecular weights for copper 2 chloride and for sodium nitrate, which makes this a little easier. So the first thing you have to do is whenever you're given gram values, when in doubt, convert those to moles. And so we're going to convert 15 grams of copper chloride to moles and 20 grams of sodium nitrate to moles. So this ends up being about 0.111 moles, and this ends up being about 0.235 moles. Whenever you're working with reactions and doing limiting reagents, you have to be working in moles. You have to be working in moles. Okay? So now let's actually answer this question. Here's our reaction, our balanced molecular reaction. We have copper 2 chloride plus 2 sodium nitrates yields these products. And we started with 0.11 moles of copper 2 chloride and 0.235 moles of sodium nitrate. And so the way that we've done it in our class is to start with these, so 0.111 moles of copper 2 chloride, and we're going to convert that into one of the products. And so if we look ahead, it says, let's see, what's it asking? Sorry. It says how many grams of sodium chloride. So sodium chloride is this. So let's convert the starting materials into that product. So we're going to convert copper 2 chloride into sodium chloride. In order to do that, we have to use the stoichiometric coefficients. So we're in units of moles of copper chloride now, so we'll do 2 moles of sodium chloride for every 1 mole of copper 2 chloride. Now, where did these numbers come from? They came from the stoichiometric coefficients. So the 2 came from here, and the 1 came from here, right? Okay, so if you do that, what you end up getting is we get 223 moles of sodium chloride. And what's our action word here? Sodium chloride is a product, so that's moles of sodium chloride that is produced. Okay? So now we have to do the exact same thing, but for the other starting material. So we have 0.235 moles of sodium nitrate. We're also going to convert that to moles of sodium chloride. We're going to do the exact same thing. So times 2 moles of sodium chloride. But now it's for every 2 moles of sodium nitrate. And where did these numbers come from? Well, this 2 came from there, and this 2 came from there, right? Again, we're using the stoichiometric coefficients to convert between moles of different ionic compounds in the equation. This comes out to be about 0.235 moles of sodium chloride. Again, that's produced. Okay? So, what this is saying is that if we start with 0.11 moles of copper chloride, we're going to produce 0.223 moles of sodium chloride. Theoretically. It's also saying that if we started with 0.235 moles of sodium nitrate, we're going to produce this many moles of sodium chloride. So which one of those starting materials resulted in the least amount of product form? Least amount of product formed. Well, that would be the 0.111 moles of copper chloride. So if you just look ahead really quick, what is the limiting reagent for this reaction? Well, that's going to be the copper 2 chloride. The reason for that is because it resulted in the least amount of product being made. It resulted in the least amount of product being formed, right? Because you see that 0.223 moles of sodium chloride is smaller than 0.235. Okay, so what's the question that we were just working on asking, though? It was asking for how many grams of sodium chloride can be formed. So here we were working with moles of sodium chloride. So if we know that copper chloride's the limiting reagent, then this value here is actually how many moles of sodium chloride are produced. So we know that 0.223 moles of sodium chloride are produced. If we use its molecular weight, which is 58.4, we could do 58.4 grams per 1 mole of sodium chloride, and that's going to be about 13.03 grams of sodium chloride produced. And that is the answer to this question. And so what's important is that you understand that the limiting reagent determines the maximum amount of product that can be formed. Okay? So let's just write that down really nice. So the limiting reagent determines the max amount of products formed. Okay? That is the maximum amount of product that can be formed. Okay. We also determined that the limiting reagent's identity was copper 2 chloride, and that's because it resulted in the least amount of product being formed. Okay, number 6. How much excess reagent is left over? So, in order to do this, we need to remember that the limiting reagent tells us two things. One, it tells us how much product can be formed, right, just like here. And it also tells us how much excess reagent has been reacted. So our limiting reagent was the copper 2 chloride. So we start with that. So start with limiting reagent. So we have 0.111 moles of copper 2 chloride. We want to convert that into moles of sodium nitrate over 1 mole of copper 2 chloride. The reason why we're converting it to moles of sodium nitrate is because since we said that copper chloride was the limiting reagent, that means that sodium nitrate must be the reagent in excess. Right? So this is our excess reagent here. And when we do this calculation, what we find is that 0.222 moles of sodium nitrate reacted. When you're looking at a reaction, okay, I'm going to erase some of this stuff. When you're looking at a reaction, and I convert from moles of copper chloride to moles of sodium nitrate, what you're solving for is how many moles of sodium nitrate need to react with that many moles of copper chloride. If, for example, I convert from moles of copper chloride to moles of sodium chloride, what that calculation is saying is how much sodium chloride was produced, right? So you have different action words depending on what it is that you're doing. So that many moles of sodium nitrate reacted. Well, we started with I think it was 20 grams. Yep. We started with 20 grams of sodium nitrate before the reaction started. And that was 0.235 moles. We used 0.222 moles, which we just solved there. So to figure out how much is left over, we need to take the difference, which is equal to about 0.013 moles left over. Okay? And so this question just says how much excess reagent is left over. So we just solved for moles. You could convert that to grams if you wanted. So 0.013 moles of sodium nitrate times its molecular weight is 85 grams per 1 mole. That equals about 1.1 grams left over. But the important thing is that both of these answers are fine. It didn't specify whether or not it wanted you to solve in moles or not. But this is how much sodium nitrate, which is our excess reagent, is left over. Okay? The next and final question asks about percent yield. So it says if 11.25 grams of sodium chloride are formed in the reaction, what is the percent yield? So theoretically, right, we think that based on our calculations up here, about 0.223 moles of sodium chloride can be produced, which we calculated to be 13.03 grams, right? That's our theoretical amount, 13.03 grams. Theoretical means we did a calculation. So this is from the limiting reagent calculation. Right? That is, if everything goes perfectly right, we're going to get 13.03 grams. And that's determined by our limiting reagent calculation. That's what's the maximum amount that can be produced, okay? The question says, though, that when the experiment was actually done, they actually yielded only 11.25 grams. They didn't get the 13.03. Maybe something went wrong. Maybe someone measured something wrong. Maybe they didn't let the reaction run long enough. There's lots of reasons why it might not have worked out perfectly. So to calculate percent yield, you take the actual yield over the theoretical yield and multiply it by 100. So we have 11.25 grams over 13.03 grams times 100, and that is about 86.3% yield. Okay, and that is it. Thank you.